All right, so the next shape we're going to study area for is a triangle. Of a triangle. So again, I'm making these notes. This would be something you would do Tuesday, so I'll put Tuesday's date on it. And trying to figure out, I have a magic show, but I'm going to have to wait and show it to you on Thursday. But I can do an outline of it. I like to do some work with index cards. So what I can do is cut a rectangle on a diagonal. So that means a corner to a corner. And then I'm going to label some things. Okay, so this is your length, and we can also call it base. And then this would be your width, but we could also call it a height. Now, why do we get to call it a height? Because we have right angles, right? Rectangles have right angles. Okay, so if I cut along that diagonal line, and I stand them up, we've got this guy that here's the base, and here's the height. I know that looks funny, doesn't it? And then that's the guy from the top, and I've just rotated him, and the guy from the bottom, I rotate him. And we again get a base and a height. And because those numbers are exactly the same exact letter and so on and so forth, what this tells me is that I get two congruent, and remember we talked about meaning the same shape, same measurements, same area, same everything, two congruent triangles from one rectangle. And that's going to be the case anytime I go from point across it diagonally to another point. And we call those points vertices. We'll talk more about that too down the line, okay? Oh, that's funny, I wrote rectangle. It's rectangle, not rectangle. So two congruent triangles from one rectangle, right? So that kind of ties into how we figure out area. So let's go back and let's do area of a rectangular parallelogram. Would be A is equal to the base times the height. But on the other side, the area of a triangle so if you think about it, a triangle is just one of the two congruent figures. So if I want to figure out the area of a triangle, it makes sense that I'm going to actually use the green guy. It's going to be the area of the rectangle, but I only want half of it. I only want one triangle, so that's the big deal, okay? So let me write that definition here. So this is your, sorry, I'm all over the place right now. So this is the new formula for the area of a triangle. It's half that of the area of a rectangle. So the definition I wanted to go back is the word congruent again, such an important word in geometry. You'll hear it all the time when you get into geometry class in high school. So these are going to be figures that have the same shape and same size. That means they are identical, okay? They're not just fraternal twins, they're identical twins, okay? So in the event we have this happening, also what's the same is the area. Also that's the same is the same perimeter, distance around the outside of the shape, okay? So we're going to do a couple of examples. I think I can fit them both on here. So same thing as yesterday, we're going to A, find area, and B, find something that's missing. So find the area of the triangle. I may have to do a second page for the other guy. This may not give me a lot of room. So triangles can come all sorts of directions. You know, you've got several different types of triangles. You've got acute triangles, obtuse triangles. You've got equilateral triangles, equiangular triangles. By the way, an equilateral triangle, all the sides are equal. And an equiangular, all the angles are equal. They're the same triangle, okay? An equilateral triangle is equiangular. You've got triangles that are scaling. You've got triangles that are isosceles. Scaling means none of the sides have the same measurement. Scaling means, or isosceles means two of the sides have the same measurement. You can have a right triangle, okay? All sorts of different things. So this guy is 12.1 meters. And then for a triangle, we need a height. So height is the same thing in a triangle that it is for a parallelogram. It's from the highest point of the triangle to the lowest point, okay? It's got to meet at a right angle. That's going to be the height, right? Okay, so I'm going to erase that. And that's going to be, I'll put over here, height. And then we'll give it a number of 6.4 meters. Okay. So, our area for a triangle is 1/2 that of a parallelogram or a rectangle. So we're just going to go ahead and plug in the numbers. So we've got the base is the 12.1. times the height is the 6.4. So the height is always going to be the number that is next to the wherever that line that contains the right angle. Okay. So there's so many ways to do this math, but what I'm going to tell you is, since I'm going to take half of something, I want to take half of something that's even. So I'm going to look for an even factor, which is that 6.4. I'm going to take half of it. And I usually, this is pretty simple math, so I can do this in my head. So 2 goes into 6 3 times evenly, 2 goes into 4 twice. So he's gone, and now what you're left with is 3.2. So I just did the kind of a commutative property, change the order, and associative property, let's multiply that half and that even number. So now I'm at 3.2 times 12.1. Yeah, I am definitely going to use the next screen on this one. So I'm going to go ahead and multiply as if there's no decimals. 2, 4, 2, placeholder, 3, 6, 3, add them up. Oops, didn't have any carrying I need to do. Now I go back and I investigate. And I'm going to look at how many digits came after the decimal points. I'm going to, for each number, add them up, and I'm going to get 2 digits after the decimal. So here's my decimal point to begin with, and I'm going to move it left 2 places so that I have 2 digits after it. So the answer I get is 38.72. Now this is area, so remember I'm going to have to remind myself this was meters times meters, right? So I'm going to just do it here. So I have meters times meters is square meters, okay? So I would say the area is 38 72/100 square meters. Okay? All right, I'm going to go to my next page, and we're going to do one where we're missing a piece. Okay? So let's go to that guy. So the directions here say, find the missing dimension. And remember, dimension is just, you know, the parts of what make up the shape. So for us, the base and the height. Find the missing dimension. Ooh, I got a delivery. Cool. So this time we're going to have a right triangle. And you're like, how'd you know how to predict that? Well, because I already knew what the drawing looked like. Okay, so I've got the right angle there. We've got 6 centimeters. We've got B. We have A equals 24 squared centimeters. Okay, so just to let you guys know, because the biggest angle in this triangle is a right angle, this is called a right triangle. Now, I cannot assume whether it's scalene or isosceles. I don't know that information because I don't know what all 3 sides are going to measure. In fact, I'm only going to figure out 2 sides, right? So that's not really going to help. So what do? We start with the formula. So we have A, sorry, let me go back to black. A equals 1/2 BH. So let's kind of color code what we've got here. So this is the A value is going to go here. And then we've got a 6. And because of him, that's telling me he's the height. And then our unknown is the B. So he stays B. So let's go ahead and start plugging numbers in. So the A is going to be the 24. And I'm going to keep the labels in, and I'm going to keep them all red because I want you to see what happens. Okay? And then we get equals 1/2, so it's always equals 1/2. And then B is going to stay B. And then we're going to have 6. Okay? Now, 6 has the label centimeters. Okay? So again, I'm going to kind of just do this idea so you can see how we get the label for the answer. Now, on the right side, I notice that I can take 1/2 of 6 is 3. Now I'm going to use my symmetric property, and I'm going to get 3 centimeters, or I'm going to put it at the end. So 3 times the base, and then we'll put centimeters at the end, equals. Now, you don't need to do the math with the labels. Okay? I'm just doing this for demonstration point. Okay. So now I'm going to divide both sides by the 3 and the centimeters. Okay, so I'm going to divide both sides by the 3 and the centimeters. Okay, so that goes away, and I'm left with B. And then that's going to equal, and I can do 3 goes into itself and into 24 8 times, so then I have 8. So let's explore the labels. So centimeters squared centimeters, is the same thing as multiplying centimeters by centimeters. But now I'm going to divide by centimeters. Well, a centimeter over a centimeter, anything divided by itself equals 1. So then I have 1 times centimeters, and that gives me centimeters. So all dimensions have a single label, all area has a squared label. So you would say the base, that's the part that was missing, is 8 centimeters. All right, there you go, guys. And good luck. Bye-bye now.